Jessica, and I'm also on the Fuselage team.
I'm Janae Day, and I'm also on the Fuselage team.
I'm Evan Briegel, and I am on the fin team.
And I'm Aubrey Harrison, and I'm on the fin team.
In order to produce the Nosecone, SolidWorks flow analysis was first done. From this information, we're able to gather that the von Karman shape would be the best shape for our rocket. The Nosecone will be made out of 7781 fiberglass. The mold is made out of 3 3/4-inch MDF boards glued together, and it was routed with a CNC machine. It's approximately 12 inches long, with a 3.1-inch inner diameter. The payload will be held in the Nosecone shoulder using a cast aluminum part. This is the mold for our payload bracket that will fit on the blast plate inside the shoulder that can be taken out once it lands. In order to get the payload as close as we can to the GPS coordinates, we're going to utilize a steel parachute which will be attached to the payload bracket, this Bible-like feature. Before the fiberglass can be laid up in the MDF, first must be sanded, then sealed multiple times before a final sealing coat and a final sand.
We are the Fuselage team. In order to build our fuselage, we're actually using carbon fiber filament to wind around a mandrel. So we had to actually design and manufacture a mandrel. We have 2 pieces of it here. It is in process. It will actually make a 3-inch diameter circle, which comes apart. So we can collapse it underneath the carbon fiber once it's made and hardened. It'll have some bolts in it. We unscrew it, it can collapse, and then we have our body.
So this is the electronics bay that we designed. We used it for our L1 and L2 certifications, so we designed it to slide in and out of here so we can use it for our rocket. And it has a GPS system and an altimeter here, so we can locate our rocket used with these batteries. And it will go in and out of our coupler, which will be made out of fiberglass so that the GPS system can transmit through.
This is our filament winder. It's an X-winder machine. We're going to be using that to wrap carbon fiber around our mandrel. We're just deciding on which angles to wrap the carbon fiber in to give us the proper strength and stiffness we need for the rocket fuselage. Using software for the X-winder to determine each layer and the angles for that layer, for each layer.
These are the fins for the rocket. There are 3 of them total. They are made of 1/8-inch thick G10 fiberglass. They have a wedge-shaped cross-section. There's an 8-degree taper on both sides of the airfoil on the leading and trailing edges. And they will be attached into the rocket with this little tab. This will actually be inserted into the rocket, and they will be attached with quickset epoxy. Delete.
Well, you're currently being recorded, so quiet on set.
I don't want to do your weird voyeurism videos.
Now just look up and start talking.
Oh, look at that.